All right, if everybody can look up here, please. Everybody should have a copy of this map in front of them right now. This is a map of the main floor of our school, okay, not the second floor, because the activity that we're going to do today does not involve the second floor. If it does, then all of a sudden we go from a two-dimensional analysis to a three-dimensional analysis. We're not only going X and Y, we're going X, Y, and up the stairs, which is Z. That makes our analysis a little bit more complicated. So we're going to focus on the first floor only, and everybody should have a copy of that first floor map right now. What I'd like you to do is take that copy of the first floor map that you have that looks exactly like what you see up on the board right now and turn it so that it looks like this. Turn it around so that the hallway that we're in right now, the science wing hallway, is vertical. The reason I want you to do that is because it makes the angles and the analysis that we're going to do with those angles a little bit easier to deal with if we start with an axis that is a y-axis as opposed to some axis that's at some kind of crazy angle. Here's our classroom right here. Okay? Everybody is going to go for a little walk today. Go for a 10 or 15-minute walk. You're going to do this in partners. You're going to help each other count and measure and all of that stuff and record angles and all kinds of stuff like that. You're going to all start from different spots. I don't care whether you start from my classroom or somewhere else. Although having said that, my suggestion would be to start somewhere down in the science wing because that's our straight line. That's our vertical line. That's our y-axis, right? If we start from over here, then we're starting somewhere at an angle that's not either X or Y. So my suggestion is either start right outside the classroom or somewhere down in the science wing or somewhere along that axis that we're going to call our y-axis. So you're going to go for a little walk. And you're going to go for a walk along the main floor of the school, going to various places, and then coming back where you started. Okay, the end of your trip doesn't have to be back where we started. In fact, I don't want it to be back where we started. The end of your trip, if you start right outside the classroom, maybe over here somewhere, or maybe the end of your trip is over here, or maybe it's over here somewhere. Doesn't matter. Okay? But it shouldn't be where you started. Once you're done the end of your trip, then of course you're going to walk back, but you're not going to record that extra little bit to get back from the end of your trip to where we started. All right, so how are we going to record this, and how are we going to measure this, and how are we going to analyze this? Okay, let's say that I start right outside the classroom here right now, okay, and I walked 30 meters, let's say north. Let's say this is north. It's not quite true that that's north, and that's south, and that's east, and that's west, but it's close enough that we can consider that to be the case. Okay, so let's say I step outside the classroom, and I walk 30 meters to the north. Okay, I walk right up here. I draw a vector showing that I've walked 30 meters to the north, and you can see clearly that it is straight up along the y-axis. There's no crazy angles here yet. It's just straight up along that y-axis. Well, then I'm going to make a turn. Okay, then I'm going to make a turn either right or left. Let's say I make a turn to the right and walk another 20 meters. Walk like this. That gets a little bit confusing now. Here's what I want you to do. Whenever you make a turn, I want you to draw a little grid system, a little XY grid system. So just a small one. I just made a turn. So let's draw a little XY grid system. Okay, just so that we know, just so that we have a reference point, a reference frame from where I turned. The angle right here, because of the way the school is set up, it works perfectly for us. Because of the way the school is set up with this equilateral triangle in the middle, that represents what, by the way? The little equilateral triangle that represents the Trinity. Good for you guys. Look at that. That angle ends up being equal to 60 degrees. Does that make sense? Now, if I had turned the other way, let's say I didn't go that way. Let's say I turned the other way and went down here. Then this angle would be 60 degrees. Again, we've got that little grid drawn, that little cross drawn that shows me where my x-axis is and my y-axis is. I always want to make sure I'm going to label an angle from one of the axes, either the x-axis or the y-axis. That one would be 60. If you decided you didn't want to label that one, you wanted to label this one from the y-axis, okay, that would be okay. Then this one would be what? Sorry, that's not 60 actually. This one's not 60 degrees. The one that I just labeled. This one would be 30 degrees. This one here would be 60 degrees. Does that make sense? Your angles from either the x-axis or the y-axis will be either 60 or 30. If it's the smaller of the two, then obviously it's going to be 30. If it's the bigger of the two, then obviously it's going to be 60. So that's kind of your way of keeping that straight. Does that make sense? Okay, when I labeled my angle over here, when I went this way, you could see that clearly this was the smaller of the two angles, so this would have been 30 degrees. If I had wanted to label it from my y-axis, it would have been 60. You don't need to label both, either from the y-axis or the x-axis. And let's say that I made that trip and I went over here. I went over here somewhere, okay? Let's say I wanted to go up here now, up towards the gym. What kind of angle do we have here? It doesn't matter what kind of angle we have, what kind of angle we turned. What matters is what kind of angle we turned relative to either the x-axis or the y-axis. So let's once again, at my turn point, draw a little cross. Now I want to label either 30 degrees or 60 degrees. This is my smaller angle. This is my bigger angle. This one's going to be 30. This one's going to be 60. Doesn't matter which one you label, as long as it's from either the x-axis or the y-axis. Does that make sense? Is that clear for everybody? So this becomes much easier if you're looking at the map like we are right now. That's not the way we usually look at the school map, but it becomes a lot easier to deal with the angles if we do look at it this way. It also becomes a lot easier if we start somewhere down here in the science wing. If you start somewhere else, which is possible to do, then it's probably a good idea to rotate your map that way, to rotate it differently than we have right here. So for instance, if you start in the math wing down here, rotate it so that that is your y-axis, as opposed to the science wing being your y-axis. Is that okay? Doesn't matter where your y-axis is, really. I've suggested this. It doesn't really matter as long as you're consistent through the whole thing. Once you walk up here from the science wing down into the math wing, okay, if you start at the science wing, don't turn your map around. Okay, you still want to have the science wing as your y-axis, and you still want to have your angles measured relative to that cross that's based on the science wing being your y-axis. Right? So you're going to go in pairs. Okay? You're going to go for, let's say, 10 to 15 minutes. Right now I've got 10:54 on my watch. Let's say you'd be back by, after I'm finished going over this stuff with you here, you'd be back by 11:10. Okay, back by 11:10, according to the clocks in the hallways. Go in pairs. Each person is going to do, hold on, Lane, grab a seat. Each person is going to do their own vector walk. The reason I want you to go in pairs is so that you can discuss it, so that you can kind of look at it and say, oh, geez, is that a 30 or is that a 60? What do I label that as? Right? So you can talk about it with your partner and label it properly that way, okay? Each person, I want to have at least 4 turns. Got it? Now, some of those turns, maybe you're walking down the math wing. Okay, let's say maybe you're walking down the math wing like this. Some of those turns may be like this. And then back like this. Okay, that's okay. Even if you turn back upon itself. Sorry, question, Fraser? That's a good question. Okay. How do we know about the angles, first of all? Well, again, we draw a cross. We draw a cross at every turn. And at every turn, measured from either the x-axis or the y-axis, there'll be either a 30-degree angle or a 60-degree angle. So you know which one's 30, you know which one's 60 based on the size. So that's easy. You don't need to bring a protractor with you to measure that. How do you know how far you've walked? Okay, and that's important, obviously, Fraser. It's a good question. Okay, we can take a tape measure with us. Okay, we can take little 15-centimeter rulers with us and take about 6 years to do this activity, or we can just get a pretty good estimation of how far we've walked with a pace. And that's what we're going to do here today, just to save a little bit of time, is we're going to pace it off. Now, you don't know how much your pace is. Is it 0.9 meters? Is it 0.92 meters? Doesn't matter. Our units here will be paces, not meters, not feet, not miles or kilometers or whatever. It'll be paces. So it's, instead of being 30 meters at 30 degrees south of west, it'll be 36 paces at 30 degrees south of west, right? We're going to do it. We're going to draw our diagram using paces, and then we're going to analyze the diagram that we have and find our resultant displacement. In other words, add all those vectors together using paces as well. Does that make sense? All right. If there happens to be, and I'm not anticipating this, but if there happens to be a fire alarm, don't walk around to this door of the school and go out. Just go out the closest door and then meet us in the back parking lot. If there happens to be a lockdown, which I'm not anticipating either, then don't walk through the school pacing your distance off. Oh, was that 30 degrees or 60 degrees? Just get somewhere if there happens to be a lockdown. It doesn't even matter if it's here, right? In fact, if it's not here, so much the better, because that means there's more room in that back room for me if the rest of you are somewhere else. All right, I've got 10:57. Let's go till 11:12. Be back at 11:12, please. All right, everybody's gone on their little vector walk here, and everybody has some data. There's some people that are a little bit confused about the angles still, though. Okay, first thing first, when you're analyzing these angles, you have got to make sure, everybody's look up here, okay, just drop your pens, look up here. You have got to make sure that you have a straight line up or across. Okay, my suggestion is straight line up. Okay, we start in the science wing. This is our y-axis. Let me just draw a line here. A nice big red line here. Okay, this is our y-axis. Now, let's say that you walk up that way. Okay, we walk up this way a certain distance from here to here. And then we make a turn. Okay, that turn, let's say, goes down here. Well, we need to know what angle we made that turn at. Not the angle between necessarily the way I was going to the way I'm going now, but rather the angle between one of the axes, either the x-axis or the y-axis, and the new direction. So for instance, let's go with that fancy, what color do we call that again? Fuchsia. Let's go with that fancy fuchsia color again. Let's draw a little cross. That cross has to be drawn well. Okay, it's a good idea, in fact, to use a straight edge to draw it. Make sure that that cross has a vertical line that is completely parallel to that red line that I drew, that first line that I drew. Okay, make sure that it has a side that is completely perpendicular to it. Okay, I don't want to see a cross that looks like this. Okay, that doesn't work for us. Okay, you're not going to get good data if you draw a cross that looks like that. It has to be parallel and perpendicular to that red line. Has to be perfectly parallel and perpendicular. Otherwise, you're going to have a really tough time seeing which is the 30-degree angle and which is a 60-degree angle. So we get to this spot up here. As soon as I make a turn, I draw a little cross. Okay, you can see that there's one line that's parallel to that red line. There's one line that's perpendicular. My new direction, my new vector, my second vector, can be measured from either axis, either the vertical fuchsia axis or the horizontal fuchsia axis. If I measure it from the vertical, you can see that looks like a pretty big angle. From the horizontal, that's a pretty small angle. Well, one of them's 30, one of them's 60. Which one's going to be which? I think it's pretty clear that this one's my 60-degree angle because that's my bigger one. Okay, you label that as 60 degrees. Or you label the other one up here as 30 degrees. I don't care which. Okay, as long as you don't go and measure this angle right here. Okay, get either 30 or 60 or the odd time. Okay, and this would be very rare, but it's conceivable to get a 90 if you were to say make a turn. If you were to say go up here and then turn right, then that would be a 90, right? It's going to be either 30 or 60 99% of the time, but it's possible to have a 90-degree turn in there as well. Okay, 30, 60, or 90. I don't want 120s. I don't want 45. I don't want anything but 30, 60, or 90. So I make this walk up here. and then I turned down here, and then I went over here. Okay, and then let's say I went down this little hallway that takes you outside right here. Okay, what does that vector diagram look like? Well, I don't have any angles labeled here yet. Let's label all of those angles here right now. Okay, let's draw a little cross. Okay, make sure that I've got a vertical line and a horizontal line. Okay, I don't care whether you measure this angle as 30 or this one is 60. It's the same thing. Okay, my first new one is labeled. Can you guys see that? Should I do that in red? Maybe a little bit brighter there. That's going to be 60 degrees, right? Well, now my next one, my next turn is right here. Okay, that's not completely vertical. Okay, so that's a polar line that I drew there. So I want to change that a little bit so that it's completely vertical, so that it's completely parallel to that big fat red line. Now, I don't need to measure anything right in here because that's the end of the vector. I already measured the direction of that vector. I need to measure the direction of my new vector. This vector right here. Now, I got a couple of options. I can measure this angle right here or this angle right here. The smaller one is going to be 30 degrees. The bigger one would be 60 degrees. It doesn't matter which one you measure, as long as you measure one of them, either 30 or 60 from either the x-axis or the y-axis. There's one more turn in here, so I'm going to draw one more cross. Once again, a perfectly vertical line and a perfectly horizontal line. This new vector, you can see has an angle right here measured from the x-axis, right here measured from the y-axis. The first one that I showed you, that's the bigger of the two angles. So that's going to be 60 degrees. Had you labeled this one in here, that would be 30 degrees. Now if you take away, just make sure that I've got this all penciled in here. If we take away the map of the school, okay, and if we take away that red line, then we've got a vector diagram that we solved on today's quiz, that we solved yesterday several times, right? All we've got now is 4 different vectors. They're all at different angles, okay? Vector 1 going straight north, vector 2 going 60 degrees west of south, I should say. Vector 3 that's going 30 degrees north of west, and then vector 4 that's going 60 degrees south of west. Does that make sense? What do I want you to do with this? What do you think I want you to do with this? I want you to find your, go ahead. Okay, let me deal with that in just 1 second, okay? What I want you to do with this, I want you to find 2 things. Number 1, the distance traveled. Okay, the distance traveled is the world's easiest problem. If you walk 10 meters, and then you walk 5 meters, and then you walk 10 meters again, your distance traveled was 25 meters, regardless of what direction you went, because distance is a scalar. Get the distance traveled. Add them up, don't pay any attention to direction for distance. The second thing that I want you to get is the displacement. The displacement is add all these vectors together, paying attention to direction. In other words, get rid of funny angles. And once you get rid of funny angles, then break them up into x's and y's, add them up, do the Pythagorean theorem, the inverse tan function, and then you've got the sum of the vectors, which is your displacement. Right, good? Yep. Is that okay? All right, that's what I want you to do now. Take your vector diagram and resolve it. Get the sum of these vectors. Get the total displacement.